Multiplying radicals. Before we start, let's review the product property of roots, which says that a radical with an index of a and a radicand of x times a radical with an index of a and a radicand of y equals a radical with an index of a and a radicand of x times y. So for example, if I have the square root of 2 times the square root of 3, that equals the square root of 2 times 3, which equals the square root of 6. So let's try an example. Let's say I want to multiply 2 times the square root of 50 times 4 times the square root of 5. I start by multiplying my coefficients. 2 times 4, which is 8. And then I have 50 times 5. Okay, now I want to write my 50 in terms of its prime factors. So let me make a factor tree over here. I have 50. I know that 2, which is a prime number, goes into 50 25 times. And I know that 5, which is a prime number, goes into 25 5 times. So 50 equals 2 times 5 times 5. All right, so let me rewrite 8 times the square root. And this 50, I'm going to write it as 2 times 5 times 5. And then I have one more factor of 5 right there. Okay, now I'm going to rewrite this as 2 times 5 times 5 squared. So I got from here, 5 times 5 is just 5 squared. The reason I did that was to identify the perfect square. Okay, since I've got the square root of 5 squared, I can just pull this 5 out from the radical, right? The square root of 5 squared is just 5. So I can bring that outside the radical. So I have 8 times 5 times the square root of 2 times 5, which is 10. Then I have 8 times 5 is 40 times the square root of 10. That's my final answer. Okay, let's do one that's a little more difficult. Let's multiply the cube root of 4x squared y times the cube root of 16x squared y squared. 16x squared y squared. That equals the cube root of 4 times 16, which is 64. Then I have x squared times x squared. Y times y squared. Okay, so now let's write 64 in terms of its prime factors. So I have 64. I know that 2 goes into 64 32 times. I know that 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. And 4 is 2 times 2. So 64 equals 2 times 2 times 2 times 2 times 2 times 2. All right. Now, since I have a cube root here, I'm looking for perfect cubes. So 2 times 2 times 2 is 2 cubed. And then I have 2 times 2 times 2 here. That's 2 cubed. So I can write 64 as 2 cubed times 2 cubed. Okay, here I have x squared times x squared, which equals x cubed times x, and here I have y times y squared, which equals y cubed. Okay, so I've identified the perfect cubes. I've got this one, this one, this one, and this one. And all of those can be pulled outside of the radical. So I have 2, 2, x, and y. And then inside the radical, I'm left with just x. This can be simplified further. 2 times 2 is 4. X, y, times the cube root of x. And that's my final answer. Thanks for watching.